Alright, so here we are on lesson 7, unit rate as the constant of proportionality. So, unit rate and constant of proportionality, we hear about a lot. Just remember that these two are the same. Whoop, page jumped. These two are the same thing. Alright, so we kind of use them interchangeably. We'll talk about unit rate and we'll talk about constant of proportionality in the same way. But to refresh our memories, and so we have it in this note packet as well, remember that our constant is k, and that is y over x. And we know that money goes in the numerator. And we always like to put time in the denominator. Alright, so make sure you have that up top just so you have something to look back at. Example 1 says National Forest deer population in danger, and it says wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do the conservationists need to be worried? First question asks, why does it matter if the deer population is not constant? Don't worry so much about that. You'll learn about that in science class. Part B, though, says, what is the population density of deer per square mile? So this per square mile is our key that we need to find the constant. Right? We need to find a unit rate or a constant of proportionality. So we're going to make a table. So we're going to have miles first, and we're going to have that be our x, and then our deer will be y. So based off of what they told us, we know that in a 16 square mile area there were 144. In a 13 square mile, there were 117. And then in a 24 square mile area, there were 216. So now we need to find the unit rate. So we're going to do y over x, so 144 over 16, which if you put that in your calculator is 9. 117 over 13. When you plug that in, also gets you 9. And then 216 over 24, which will also get you 9. So we know that the unit rate of deer per 1 square mile is 9, which means that our constant of proportionality is k equals 9. And now it says to explain the meaning of the constant of proportionality. So this would mean that there are 9 deer per square mile. Part C says to use the proportional relationship equation y equals kx to determine how many deer are there for every 207 square miles. So we know our k, so we're going to have y equals 9x. And we know that we have miles, which is x, so we're going to do 9 times 207. And if you do that in the calculator, you get 1,863. And this would be 1,863 deer. And then part D is kind of similar. It says to use the equation to determine the number of square miles in which you would find 486 deer. So we're using y equals 9x, but now we know the number of deer, and we know based off our table that is y. So we have 486 equals 9x. We divide both sides by 9, and when you do that, you get 54 equals x. So our answer would be 54 square miles. Right? So you can go ahead and flip to the next page. Up at the top, the box has just got some key vocab terms. We've talked about the constant, a variable, constant of proportionality. So they're just for your reference. Alright, now we're going to look at example 2. Before we do example 2, we need to talk about input and output. So we have input and we have output. So input is always going to be our x values. Input is what you put in and output is what you get out, so our output will be our y values. And we'll keep using this as we move through our note packet. So this example says that Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. Brandon and his mother determine that they can fit 36 cookies on 2 cookie sheets. And they're asking, is the number of cookies proportional to the number of cookie sheets used in baking? Create a table that shows the data for the number of sheets needed for the total of number of cookies baked. So first we need to determine our x and our y, our input and our output. So our input, kind of what determines everything, would be our cookie sheets. Because the number of cookie sheets determines how many cookies or output that we can make. Alright, and they told us that they can fit 36 cookies on 2 sheets. So if we wanted to know how many they could fit on 1 sheet, we would do 36 divided by 2, which is 18, so they can fit 18 on 1 sheet. So the unit rate then would be 18, which means our constant of proportionality would be k equals 18. And now if we explain the meaning, we would say that they can fit 18 cookies on 1 cookie sheet. Alright, so that's all that we're going to do together. I do want you to try part F on your own, and then don't worry about the next page. We will do that in class all together tomorrow. So go ahead and try part F, and if you have any questions, bring those to class.